Okay guys, so next thing we're going to be talking about is properties of parallelograms. So first of all, let's make sure we know what a parallelogram looks like. So it's this kind of shape here. So the most noteworthy thing about a parallelogram is that it has two pairs of parallel sides that are opposite from each other. So in this case, if I label this as A, B, C, D, first of all, we would call this parallelogram A, B, C, D, okay? And we would say that AB would be parallel to CD, so that's why it's called a parallelogram. And also, the other opposite sides are also parallel. So we have AD being parallel with BC. So the first noteworthy property for parallelograms is that opposite sides are parallel. Okay. And the other thing that we should take note of is the fact that opposite sides are also going to be congruent. So I'll denote that by writing one line here, and I'll have a double line over here for those two. So what I would write here is that opposite sides are not only parallel, but they're also are going to be congruent. Okay? So we have opposite sides being parallel and congruent to each other, right? That's the first two properties. Now I want to say something about the angles inside of this shape, right? So in the first lesson of this chapter, we spoke about the interior angles of a polygon, right? So we know that the sum of the interior angles of a polygon is 360, so that's useful. But in this context, we can say even more about what each angle measures. So one thing that I can say for sure is that opposite angles are going to be congruent, and this is the way that I could show that. So for example, angle B and D would be congruent, and angles A and C would be congruent, right? So I'll write that in here. Opposite angles are congruent. Okay, good. And well, what happens with adjacent angles, right? So let's look at adjacent angles, meaning angles that are next to each other, right? So angles A and D would be considered adjacent angles, right? So too would angle A and B be considered adjacent angles, right? But what can I say about, for example, angle A and D? Well, if I look at this, right, I can draw here in yellow the fact that these lines are parallel, and then we would have AD being a transversal of those parallel lines, right? And so what we notice is that the two angles in question, these ones, these are what we would refer to as same side interior angles, right? So when we have same side interior angles, we know that they are supplementary, right? So we can say that anytime we have angles that are adjacent inside of a parallelogram, they're going to be supplementary. So let's write that in. Adjacent angles are supplementary, meaning that they add up to 180. Okay? And the final property for parallelograms has to do with the diagonals. So let me draw in the two diagonals here, and the point of intersection, we'll call that point E. Okay? And what I would say for this one is I would say that the diagonals have a special property, that is that they bisect each other, right? So when I say that they bisect each other, it means that line AC cuts line BD in half, and vice versa. Line BD cuts line AC in half. And so the way that we could show that on the picture is that we can draw a single mark here and a single mark here. I'm making it thick to differentiate it between the thin marks there. And then I'll draw two thick lines here and two thick lines over here. So you see that this is equal to this, and that this is equal to this. Okay? So that completes the 5 basic properties of parallelograms. Next, we're going to look at how we can use those properties in actual problem solving. All right, so here's our first question using properties of a parallelogram. So we're given the fact that this is 15, and since opposite sides are congruent, we can determine this would be 15, right? So we could fill that in here. Similarly, since this one is 8, we could determine that this one is 8. All right, so we could fill that in here because opposite sides are congruent. Next thing we remember is that opposite angles are congruent, so we could determine that angle B would have to be 68 degrees, right? And then we remember that adjacent angles are supplementary, right? So whatever angle A is, it has to add up to 180 with 68. So if I do 180 minus 68, that gives me 112, and that could go in for angle A, right? And last but not least, angle C would also have to be 112 because, once again, opposite angles are congruent. Okay? So let's have a look at this next one here, number 3. So the first thing that I can recognize is that I would be able to figure out opposite sides. So if this is 18, this would also be 18. And if this is 27, this one would also be 27. Right? Now the next information they're providing is that RT is 30. And since the diagonals bisect each other, right, I would want to take 30 and divide it by 2. In other words, cut it in half. And that gives me 15. And so 15 would go for each part of RT, right? So RT extends from here to here. So if the whole thing is 30 and it's getting cut in half, that means that these pieces are equal, so they each have to be half of 30, or in other words, 15. Okay? So now we can begin to fill in. All right, UT is 27, ST is 18, right? VS, we don't know yet. VT, we know to be 15. Okay? So, yeah, the next thing to determine is VS, and knowing that this is 7, we can conclude that this must also be 7, and that's because since the diagonals bisect each other, they're both getting bisected, not just the RT, but also US is being bisected, in other words, cut in half into 2 equal parts. Okay? All right, so let's try this next one. So the next one, they didn't put the numbers into the picture, so we have to do that ourselves. XY is 15. All right. WX is 22. Okay, ZX is 52, so ZX is 52. Sometimes you can write that sort of over here if you can't sort of draw it into the picture. WT is 23, so if WT is 23, okay. And then we have some information about angles. So let's hold off on the angles for now. So right away, let's try to figure out what we can based on these numbers we have so far. So the first thing I would say is that WX has to be equal to ZY, so this should also be 22. XY being 15 means that WZ would also have to be 15. Okay. Let's see. So what else could I determine? If this is 23, then we would say that this piece here would also have to be 23 because the diagonals bisect each other, right? And the other thing is, since ZX is 52, right, if I divide that by 2, that equals to 28. Is that right? No, sorry. 26. And so 26 would have to go for each half of that long diagonal, right? Because they're each equal to each other and they have to add up to 52, so each one has to be half of 52. Okay, so we figured out all of the different sides, and we could begin to fill those in. So ZW is 15, ZY is 22, TX is 26, WY is 46, right? Altogether, if I do 23 plus 23, that's 46, okay? And now they're asking about angles. So now we have to begin looking at the angles. Okay, so let's go back to red for the ones that are given. So WZY is 72. Excuse me. So WZY is 72. I like to write that number outside since it's the total angle and not each half. Or not, I shouldn't say half, but because they're not cut in half. That's not a property. But anyways, WXT is 35. So WXT is 35. So this one I'll write on the inside since it's just that portion of the angle. Okay. ZWT is 59. So Z to W to T is 59. Okay. So the next thing I'll have to do is to figure out basically the missing angles that they want me to figure out. So let's see what they want me to do. So how about TZY? So let's look for TZY. So TZY is over here. Yeah, so this one, we haven't spoken about this property yet, but I'll kind of say it now, is that when you draw the diagonals in, you're going to get alternate interior angles formed, right? So if I draw these diagonals, or excuse me, those are the parallel lines, and then the diagonal would cut across like this, that would be representing a transversal, right? So this is where we could look for alternate interior. So 35 would be equal to 35 over here, okay? And that's coming from the fact that these are alternate interior angles of parallel lines. Remember, these are parallel lines, right? So I'll erase that for a moment. And we'll look at the next number. So that one we got to be 35. XYZ. Let's look at XYZ. So XYZ is this angle here. Notice it's next door to this. In other words, it's adjacent to angle Z, right? And if Z is 72, we could do 180 minus 72 because we know that adjacent angles are supplementary, okay? So we find that that angle is 108. We can fill that in here. Next, we're looking for XWT. So XWT is located in this spot, all right? Well, let's think about how we could figure this one out. Okay, so here's the idea. If angle Y is 108, then angle W would also have to be 108, right? But we don't want angle W, we want just that portion that's on the right-hand side. Well, we know the left-hand side portion is 59, and this is unknown, but we know they have to add up to 108. So couldn't I just do this, right? And let's see, when we subtract this, if I do, was it 49? Sorry. I need to add 1 to get the 60, and then I would need to add 40, so 41 and 8, yeah, 49. I believe that's right. Okay. All right, so that angle there, the missing angle is 49 degrees, so we'll fill that in. Okay. Next up, XYT. So where is XYT? XYT is in this bottom sort of corner here. It's this angle. Well, the same argument can be used as we used earlier, where if these are parallel lines, and this one is a transversal, right? Then this being 59 means that this one would be 59, simply because they have to be alternate interior angles, right? So let's write 59 degrees in for that. Okay. And then we're basically all set. So I'll have you guys now try numbers 2, 4, and 6 on your own, and we'll be back to go over those in a moment.